Dear students, welcome to s.mathguru classes. So we solve some problems about first order partial differential equation. We consider the remaining problems of the same types by using Lagrange multipliers, method of Lagrange multipliers. So this one given example, this solve p plus 3q equal to 5z plus 10 y minus 3x. This problem is given. Now we want to solve this problem by using Lagrange method of multipliers. So this one given p plus thrice q 5z plus 10 y minus thrice x. So I recall the formula. If capital P small p capital Q small q equal to capital R, then the auxiliary equation equal to dx by capital P dy by capital Q and dz by capital R. These are auxiliary equation. If we get this type of equation, this on this. So here capital P means 1 and capital Q means 3 and this whole is R, this one. So therefore the auxiliary equations are dx by 1, this capital P means 1, dy by 3, dz by 5z plus 10 y minus thrice x. We get this. Now we consider first two pair, dx by 1, dy by 3. This implies dy equal to 3 dx. We get this. Integrate both sides. We integrating both sides. So this implies y equal to 3x plus c1. This implies y minus 3x equal to c1. We get this. This is number 1 we consider. This is number 2. We get this one. Next we consider first and last. Again dx by 1, this equal to dz by 5z plus 10 y minus thrice x, this one. So this implies dx equal to dz by 5z plus 10 c1, because we know y minus 3x equal to c1. Putting this c1 here, so we write using 2, this equation. Now we integrate both sides. Integration dx equal to integration dz by 5z plus 10 c1. Now 10 c1 is constant, 5 is this, z is variable, so this is x. We can write this one 1 by 5 dz by 5z plus 10 c1. We write this. So numerator is multiplying by 5 and here 1 by 5. 5 cancel, we get this. But actually we know this formula, integration f dash x by fx dx, this equal to log modulus of fx plus c. If we differentiate fx, we get f dash x. If differentiation of denominator given in numerator, answer log of denominator. If I repeat, if differentiation of denominator given in numerator, answer log of denominator. So if we differentiate this, we get this is 5, this is 0, we get 5. Differentiation of denominator given in numerator, so we get x equal to 1 by 5. This is log modulus of 5z plus 10c1. This one we get plus c2 by 5 you consider, because where you get 5, we write c2 by 5. And multiplying both sides by 5, 5x equal to log 5z plus 10 c1. c1 means y minus thrice x. This is y minus thrice x plus c2. Multiplying both sides by 5, this is 5, 5 cancel, we get this one. And this one taking in left hand side, 5x minus log 5z plus 10 y minus thrice x equal to c2. We get this one. Therefore, the required solution is f of y minus thrice x, comma 5x minus log modulus of 5z plus 10 y minus thrice x, this equal to 0. This is our answer. Or we can write 5x minus log of 5z plus 10 y minus thrice x, this equal to f of or phi of y minus thrice x. Either this one answer or this one answer. Just write c1 equal to this is our, this equal to c1, this result and this result, write down together, we get this, or we can write this our answer or this one answer. Very easy solution. Consider another problem. Solve z into z square plus xy px minus qy equal to x to the power 4. We want to solve this problem. So given z into z square plus xy px minus qy equal to x to the power 4. This implies with the multiplying this one with this and this, z into z square plus xy, this is px, that means x, this is p, and minus zy, z square plus xy equal to x to the power 4. Z into x and this one, and z into y into this. So I recall the formula. If we have this type of equation, p small p, q small p, q equal to r, then auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. These are auxiliary equation. So here this whole is capital P, this one is small p. This whole is capital Q, this one is small q, and this one R. So the auxiliary equations are, dx by zx into z square plus xy, dy by minus yz z square plus xy, and dz by x to the power 4. This is number 1 we consider. Now first we consider first pair. Now dx by zx z square plus xy dy by minus yz z square plus xy. And here this z cancel, this cancel. We get dx by x minus dy by y. We get this one. And we integrate both sides. So this will be log x minus log y plus log c1. This implies log x plus log y equal to log c1. This implies in logarithm if plus given we write into, this equal to log c1. Now this is xy equal to c1. This implies xy equal to c1. This is number 2. We get this. Now again we get this one. Again taking dx and last, because here we get x, here also we get x. Again we consider first and last members, dx by zx into z square plus xy equal to dz by x to the power 4. We get this one. Now dx by 1x is cancelled. We get z square plus c1 dz by x cube. We get 1x cancel, x cube, and xy means c1. So we putting x in place of xy, we putting c1. So using 1. Now cross multiply, x cube multiplying this side, this one on right hand side. This is x cube dx z cube plus c1z dz. This one multiplying this one and this one on right hand side, this. Now integrate this, x cube dx, this is z cube dz c1z dz. This is x to the power 4 z to the power 4 by 4 and c1 z square by 2 plus c2 by 4. Multiplying both sides by 4, x to the power 4 z to the power 4 2c1 z square plus c2. We get this, and this is x to the power 4 minus z to the power 4 minus 2 z square c1. c1 means xy. So we get xy z square equal to c2. We get this one. This is the second equation. First equation is this, second equation is this. This number 3 we get. We get equation number 2 and 3. These are the required equation. Solution. So we know u equal to c1 and v equal to c2. If we have two solutions, then required solution will be f of u comma v equal to 0. These are required solution. So this is u and this one whole is v. Therefore, the required solution is f of xy comma x to the power 4 minus z to the power 4 minus 2xy z square equal to 0. This our answer. Answer is this one. Very nice solution, very easy, very interesting also, but these are important for any engineering courses. It may be in second semester or third semester, it may be first semester also. Maximum times we will get in third semester or second semester. So I hope you are all enjoying. If you are all enjoying, then please like this video to share this video to your friends, and like this video and click the bell icon. Thank you.